If you leave a piece of chocolate inside a hot car, it melts. The warmer temperatures have transformed it from a thing that was solid and breakable into a substance that is liquid and messy. To melt a rock, the temperatures need to be a lot hotter than the inside of a warm car. But rock can melt, and when it does, we call it lava or magma. Melted chocolate, once it's cooled down, becomes solid and breakable. When lava cools down, it becomes a rock, but not just any rock. Rocks formed from magma or lava are called igneous rocks. Igneous comes from the Latin word ignis, which means fire. Ignis is also the root of other fiery words you might know, like ignite and ignition.
So igneous rocks are fire rocks?
Exactly. I'm Science Mom.
I'm Math Dad.
Today we're learning all about some of the hardest, most common, and lightest rocks in the world. Hello, and a big welcome to Denali watching in Costa Rica, Kendall in Illinois, Isaac in Georgia, Eleanor and Elise in Quebec, bonjour, Isabel and Luke in California, Aubrey, Lucy in Minnesota, and Catherine, Joshua, and Quinn from Texas. And a special welcome to you if you're watching the replay. I know that quite a few of our students have different spring breaks and some are off traveling right now.
Yeah, we had an eventful break, mostly housework and yard work, but we're glad to be back. And what are we talking about?
Well, Planet Earth does housework as well, rearranging things, turning things over. And right now in Iceland, there is a volcanic eruption happening, and we want to share a quick little 360-degree view with you. I'm going to put up a banner real quick so that if you want to check this website out later on, you can.
So what are we seeing here?
We are seeing a vent, and lava is coming out of the vent, and you can drag all around. This shot was taken with the drone, but it's done in such a way that you can drag it around, and it's just like you're there, and you can turn and look, and you see that lava glowing bright hot flowing out into this little valley.
Whoa.
Isn't that amazing?
That is amazing. Kind of scary. It's got to be really hot then, right?
Lava is really hot. And this is happening right now in Iceland. There are volcanic eruptions happening somewhere in the world all the time. And when lava comes out like this, the lava is melted rock. Just like if you melt chocolate, you can get liquid chocolate. If you get a rock and heat it up to more than 1,000 degrees Celsius, it will melt and turn into a very hot, glowing liquid.
And the reason it's glowing is?
The reason it's glowing is actually because anything, if you get it hot enough, you will bump the electrons in those atoms to an excited state where they have more energy. And then when they fall back down to their ordinary state, they release a photon of light. But that's a little bit of a tangent. What I want to get to is what happens once that rock cools down.
I'm getting the request for that URL one more time. So let me see if I can throw it up there.
Up at the very top.
So Iceland360VR.com.
Yep.
Totally worth checking out because when did this start erupting?
It's erupting right now. It's still going. They expect that it will go for at least another week or two, although volcanoes tend to be unpredictable. And that's the scientists' best guess is that this will keep going for another few weeks.
Just started last week, right?
It just started last week. So once that lava cools down, it turns into a rock. I have a piece of rock here called basalt, and you can see that it has little holes in it.
Yes, it does.
And when basalt or lava comes out of the ground, a lot of time it cools into basalt. That is the most common igneous rock. And I want to take you on a quick little tour of some photos of different lavas. So we're going to start out in Hawaii. You can do it, Math Dad. There we go. We're going to start out in Hawaii. This is a fountain of lava coming out. And the reason it's fountaining is because it's under pressure in where it's coming out. And there's a little crack that then allows it to come out. And the pressure of all that heat and that gas causes it to form a fountain.
It looks a little scary. I'm a very brave photographer.
You would not want to get too close to this. I'm sure this photographer had a nice telephoto lens. And the lava flows in Hawaii often flow all the way down to the ocean. And when lava meets ocean, some pretty cool things happen. The ocean is so large, it's not going to get warmed up noticeably by lava pouring into it. The lava, though, does heat up the water that it hits, and the water that it hits turns into steam. And that's why you see all of that white cloud coming up where the lava is hitting the rock.
It's boiling.
It is. Yeah. It's boiling the water, and the lava is cooling down really quickly. And in Hawaii, a lot of times it will cool down and form black sand, black volcanic sand.
Ooh, Kara points out it's creating more land.
It is creating more land, and that land is made out of basalt. That is one of the most common volcanic or igneous rocks. Now, in Hawaii, most of the lava is the type that will form basalt, but there are different types of volcanic eruptions. Not every volcano produces basalt. Some volcanoes produce clouds of gas instead of a flow of lava.
So look at that one. It's gone over top of an existing road?
Yes.
Whoa, that's a lot of lava too. That's not just a tiny little bit.
It is a lot of lava. And when you visit, if you are able to visit the island of Hawaii, or if you happen to live there, you can travel around and see evidence of old lava flows and new ones. One of the most recent ones was in 2008. And you can see there is a fissure right here.
2018?
2018. Thank you. Thank you for that correction, Math Dad. It was a fissure right here where the ground cracked open. And then the lava came out and it flowed all the way down to the ocean. And it actually ended up covering several houses and a small little subdivision. It was a really big lava flow. And up on the upper part of the island, if you look at old lava flows, you can see trees starting to grow in the cracks of that old basalt. And sometimes it will be red. Sometimes the lava will be black. Those old lava rocks will be black. They can be different colors depending on what minerals and elements the lava contained, because not all lava is the same.
This one looks really smooth compared to
this one was quite smooth.
Is this basalt as well?
Almost all of the rocks on Hawaii would be called basalt, but they don't all look the same, because depending on how they cool and what minerals and gases are inside the rocks, sometimes they will have a rough texture, sometimes they will have a smooth texture, and sometimes they can be red or brown instead of black.
Oh, way cool.
Now, we looked at our example of basalt, and now I want to talk just a little bit about liquid versus solid. This rock is solid, right, Math Dad?
Yes, indeed.
Yes, it is most definitely solid. And this bottle of soda right here is liquid. If I turn it on the side, it's going to flow. And if I opened it up and tipped it upside down, it would just pour out. This solid rock is not going to pour out, right?
Correct.
Now, what about these two items right here? Let's look right here. I have a couple pieces of pasta, and I have some candy that is stretchy, a little bit stretchy. So this piece of pasta here, this noodle here, it is solid. But if I apply pressure and I push in on the sides, it's going to snap.
Yes, it did.
And this candy, on the other hand, if I apply pressure and push in on the sides, it just bends and bends and bends.
Yeah, you're not going to snap that.
But is this a liquid?
No.
It is not a liquid. It is not a liquid. And when we're talking about volcanoes and how they form, we're going to go to page 69 of the notes, or 68 on the notes, real quick, and talk a little bit about where a lot of the volcanoes in the world come from. 67 is the page that we're on. So when we're looking at a cross-section of our Earth, the crust is up on top, and the crust is very hard and brittle. It will break easily. Right below the crust, we have rock that can be smushed, just like this little piece of candy can be smushed and bend. And then if we have melted rock that is actually liquid, we call that magma, and that rock is liquid, and it is going to either cool down and become a solid rock inside the crust, or it's going to rise up to the top and come out as lava.
The chat's saying that we should feed Math Dad. Do you see that?
Here you go, Math Dad.
I mean, the chat wants it. You've got to do what the fans ask for, man.
He appreciates this.
Thank you, chat.
So this diagram here, we have a continental plate and we have a oceanic plate. And when the oceanic plate hits the continental plate, it dives underneath and it melts. Ooh, and Noah asks, is the candy a plastic solid? I would describe the candy as a plastic solid, which makes me want to eat it less. But I don't mean plastic as in it's made out of plastic. I mean plastic in that it can bend and move like certain types of plastic can. Plastic kind of means flexible.
Now, we described part of the inner Earth as a plastic solid. What part was that?
The mantle. And I'm curious, Math Dad, if you can keep an eye on the chat, let me know if anybody knows the difference between lava versus magma. So mantle is a plastic solid. It is not liquid. Both lava and magma are liquid. They are melted rocks that are liquid, but what's the difference? Why do we call them different things?
Different scientists wanted credit for the name?
Nope, that is not why. That is not why.
Ooh, Kara says magma is what comes out.
You're going in the right direction.
Oh, Sonica says lava is out, magma is in.
That is a really good succinct way to say it. So magma is what we call melted rock that is still inside the earth, and it might be getting ready to come out. But as soon as it comes out and is above the crust, then we call it lava. Now, I have a quick question for you, Math Dad. Going back to our graph on page 67, why do we get melt when an oceanic plate goes underneath a continental plate? Why does some of that plate melt?
Well, it's crazy hot, right?
It is crazy hot, but if it's crazy hot and that causes it to melt, then shouldn't everything be melting all the time?
We get a pocket of extra heat somehow, but how, I'm not sure.
It's actually because of the water.
What?
So the oceanic plate is covered in ocean, all that water, and that water has seeped in and it has made the rock wet. There is a lot of water trapped in that oceanic plate. And as that oceanic plate goes down underneath the continental plate, all of that water changes the melting point of the rock. And that's what causes the lava, or since it's underneath, what should we call it?
Magma.
The magma to start rising up. It's this melted rock and it's not as dense as the mantle. So it rises up and we get volcanoes. If you look at the Cascade Mountain Range, there are volcanoes all the way along. And that's because of the boundary between the North American plate and the Pacific plate. The island of Hawaii, on the other hand, is very different. That is formed from a hot spot because it's right in the middle of a plate. So you have a different type of lava there than you have in something like Mount St. Helens.
Ooh, Mount St. Helens is a really destructive volcano, right?
It is. And let's go back to our slideshow real quick because we want to show a different type of lava flow. So this was a lava flow in Hawaii, and you can see that it was just like liquid rock that came out.
Some very friendly volcanoes.
It is a more friendly volcano, especially compared to this. So this is photos of the 1980 eruption on Mount St. Helens. And Mount St. Helens did not produce a lava flow that went down and out over the mountain. It produced what's called a pyroclastic eruption.
Whoa.
A pyroclastic eruption, pyro means fire and clastic means broken, so broken fire.
That's a good name for it.
This type of eruption is the most dangerous type of volcanic eruption. So lava, you definitely don't want to have a lava flow come and cover your house, but lava, you can get out of the way. A lava flow that's flowing down like that is not moving too rapidly, and you have ample warning time to evacuate. A pyroclastic flow is when you have so much dissolved gas that it erupts really violently. So this bottle of soda right here, Math Dad, if I were to shake this up and then open it up, what would happen?
A mess, a big mess. And we don't make messes around here.
No, I won't do it by the computer, but let's share a video real quick. And I want you guys to watch just how fast the entire bottle changes. Did you really think I was going to open it?
I was worried there. I was worried.
So that bottle had been shaken. I'm going to play that short little clip one more time. Watch how as soon as the lid is turned, the entire liquid goes white with bubbles. And that's essentially similar to what happens inside a volcano that has a lot of gas in its magma chamber. When the eruption finally happens and all that pressure is released, you have so much gas traveling out away from the volcano that it can be incredibly destructive. And it's carrying with it tiny little fragments of lava and ash. And that ash, the gas, and little bits of lava, they can travel up to 700 miles per hour. And the temperature can be over 1,000 degrees Celsius. So imagine a 700 mile per hour wind, but if it's not, that's like the record speed. The average speed is more like 200 miles per hour. That's still really bad. Oh, yeah. So 200-mile wind on its own would be bad. But then imagine that the temperature of that wind is 1,000 degrees. And that's what a pyroclastic flow is. So Mount St. Helens is a famous example of a pyroclastic flow. A lot of it went up, but the part that went out across the landscape knocked down trees for hundreds of miles.
Are those all trees?
Yes.
Laying down?
This mountain is not Mount St. Helens. This is a mountain that was miles away from the volcano.
It's flat like somebody combed their hair.
Yes.
Look at those trees.
Oh. All of the trees got knocked down because of the pyroclastic blast. This is a photograph of a part of a building that is left after a flow in Mexico in 1982. Those things that look like wires bending out this direction, that's rebar. That is steel. Steel that was bent, and the rest of the wall is gone.
Crazy. That stuff is not easy to bend.
No, that is not easy to bend.
Took out the wall and the rebar as well.
Now, let's take a look real fast at what rocks you have after a pyroclastic flow. No, we're good right here. I want to show this rock, which is pumice and very light. And then this rock, a lot smaller. This is a piece of basalt. And if you feel them, this little rock almost feels heavier than this one here.
Yeah, this one is probably, it might float even. That's so light.
Pumice often does float in water because it's so light, and it's so light because of all of the gas that was trapped inside the magma chamber.
So Mount St. Helens had a lot of air and gas. Would it have made the pumice?
It did. It produced blocks of pumice that then were deposited, and ash, just a big ash fall that was deposited all over the land surrounding that volcano.
Cool. Whereas this is, clearly no air in here. I mean, it's hard and
much more dense.
What did we call this?
This is another type of basalt. So hold up this one here. Basalt can look really different depending on the volcano. Some types are hard and dark and black. Others can be even orange or red, and they can have air bubbles too. But pumice has a lot of air bubbles and is incredibly light. But there's another type of volcanic rock that I bet you have heard of before, and it is beautiful. It's very similar to glass.
I know what it is.
This is literally a little lava bomb. That's what they call them, because it's a piece of lava that goes up into the sky, falls down. It's round because it's shaped as it falls through the air. It cools down really quickly. But this lava bomb was made by lava that is high in silica, and it cooled down very rapidly. And that means that no crystals formed. And we get a beautiful dark interior. This is obsidian.
Yeah, it's reflective and beautiful. Now, you said this one cooled faster?
It cooled very fast. And if it cools very fast and it has a few little impurities, sometimes you get little patches of white. That's called snowflake obsidian. But what's the difference between obsidian and basalt? They're both made from lava that cools pretty quickly on the surface. Why is one like glass? It has to do with what elements they're made of. Basalt has more magnesium and iron, and obsidian has more silicon.
Like glass.
Yes, has more silica. But the real difference too is how quickly they cool down. Obsidian cools down very quickly. Basalt sometimes takes a little longer to cool down.
And that makes a difference in the chemical structure.
It does. But what if we're looking at melted rock that never makes it to the surface? What if it is inside the earth, underneath the surface, and it cools down? Well, then we call it an intrusive igneous rock. It's like it intruded into existing rock, and it just cooled down and became rock there. Whereas if it's lava that cools down on the surface, we call that extrusive.
Oh, kind of like interior and exterior.
Yes, because it came out.
Roots there. Ah.
Now, one of the most well-known intrusive igneous rocks is what our countertop is made out of. Do you recognize this, Math Dad?
That's our kitchen countertop.
That is our kitchen countertop. And it's made of a rock called?
Marble.
Not called marble.
Concrete.
Nope, not
granite.
Concrete. Granite.
There
Granite
we go.
is correct. Third try is the charm. Good job, Math Dad. Now, this granite, and here's a piece of granite that I picked up from our backyard because our backyard happens to be mostly granite. This granite has crystals. If you look at the rock, you can see differences in color. You can see these patches of it that are white, these patches that are more of a kind of a silvery color, the patches that are dark. And that's because it cools down so slowly because it's inside rock and it's insulated by all of that rock around it.
Yeah, the chat knew this. Rachel and Alana and Margaret, they saw it right away.
Awesome. Yep. And because it cools down so slowly, certain elements decide, hey, I want to be over by you. I want to line up next to you. And you have these little crystals of quartz that grow inside the rock.
Yeah, that's really cool.
Yeah. So we don't often think, a lot of people when they're first learning about rocks, they don't think, oh, granite, that came from lava. And it didn't come from lava because it didn't come from melted rock above the Earth's surface, but it did come from magma that had cooled down inside the Earth's surface.
Gotcha. I mean, it's such a beautiful texture. I mean, it looks like somebody mixed them together on purpose.
It is. And it was just formed by that slow cooling and crystals forming, similar to when you make rock candy. If you cool your sugar solution down nice and slowly, there's time for sugar crystals to form. But if you take sugar syrup and just pour it into cold water, it will be sugar glass. It won't be rock candy. It will form without crystals. Now it's time for our Where in the World mystery. You ready, Math Dad?
I'm ready.
Oh, before you read the whole entire clue, first national park in the entire world. Do you have a guess?
I was going to say Yellowstone.
And you were right.
Yeah.
You got it without the 10,000 geysers and the hot springs and the fumaroles. That really gives it away.
Yeah. Yellowstone is a pretty cool national park.
Yellowstone is amazing.
Most national parks are there for a reason. They are cool. But Yellowstone just has so much to see that it really stands out.
So in the notes, if you are participating in the Where in the World challenge, you can mark B with this little drawing of Old Faithful Geyser. And there are so many different hot springs and geysers in Yellowstone. One of my favorites is Prismatic Springs. It is enormous. And the colors from blue to green to orange that you see, that's a result of differences in bacteria. So certain types of bacteria prefer different temperatures, and you get that difference in color because of the bacteria that live in the hot water. But where does the heat come from?
It's got to be coming from underground, right?
Magma. There is actually a large magma chamber underneath Yellowstone.
Wait.
And that's what's responsible for all of the hot springs.
Does that mean it's like a volcano and it could erupt?
It's most likely not going to erupt again. Although there are different scientists studying it right now, and there's different research happening with Yellowstone. It has erupted in the past 3 times. There were 3 super volcano eruptions where Yellowstone erupted and put ash over almost the entire United States, or what was going to become the United States, because they happened a long time ago. But the heat in Yellowstone does produce geysers, and this is a photograph of the biggest geyser in Yellowstone, Steamboat. And I'll drop a link in the description to a video we did on Steamboat that you can watch if you want to learn more about geysers.
Yeah, it's super cool.
Yeah.
Super hot.
Super hot. I want to wish a very happy birthday to Shelby Stern from Illinois, who turned 10 yesterday. Happy birthday, Shelby. And special shout out to Ember, who recently got braces, which is no fun. My mouth was very sore after I got braces. And now,
I hope you guys are ready for a challenge. Go to itempool.com/sciencemom/live and prepare to be defeated.
You should prepare to be defeated, Math Dad, because
I'm not scared.
I'm going to go grab Science Puppy real fast. Which of these are not igneous rocks?
Okay, just a sec. I got a list of several rocks here. Yeah, which are not igneous rocks. So select the ones that are not igneous. Got granite, limestone, pumice, basalt, sandstone, Select any and all that are not igneous rocks. I almost missed this one myself because I selected the ones that were igneous rock, but I went back and I corrected it. I'm pretty sure.
So Science Puppy was in his little bed, so I just brought the bed in.
Oh, yeah. I see 2 categories getting lots of votes and 3 getting fewer.
Ooh, let's go ahead and reveal the answer. I'm super curious. I bet they've got it right.
All right. They said limestone and sandstone are not igneous rocks.
And that is correct. We'll talk more about limestone and sandstone next week when we talk about sedimentary rocks. Well done, you guys.
All right. Question number 2. If a volcano in Alaska erupts and lava pours into the ocean, what happens? So select all that apply. So the water boils, producing large clouds of steam. The lava cools very quickly, forming volcanic sand or larger pieces of rock. The temperature of the entire ocean increases by 1 degree Celsius. So if any of those are true, select them.
And we had a fun little graphic in the notes where you could draw what would happen when lava met the ocean. And if anybody completed that and drew an image, I hope you'll share it with us. We would love to see it. Do you want to share that real fast, Math Dad?
Yeah.
So there's on page
68?
66.
Oh, really?
Yep,
Oh.
66 of the notes. Whoops.
Oh, because we added new pages. I see.
So when you have lava versus Arctic seawater, what happens?
All right. And water boils, producing large clouds of steam. So that's going to happen for sure. And the lava cools very quickly, forming volcanic sand or larger pieces of rock. So what is volcanic sand?
So it depends on what the lava is made out of, but certain types of lava, when they hit the ocean, they'll cool down and fragment into little tiny pieces that are about sand size.
Okay.
And so you actually get volcanic sand that is produced immediately as soon as that lava hits the water. But if the lava is a lot thicker, then you'll get big chunks of rock that form as it cools down. But even a very large volcano is not going to be big enough to increase the temperature of the entire ocean.
The ocean's just too big.
The ocean is way too big.
All right. Question 3. What type of volcano formed the largest summit of the island of Hawaii? So we're talking about the big island of Hawaii.
Ooh, and this is sort of a bonus question. If you looked at the notes, the answer's there in the notes, but we actually didn't mention this out loud today in class, so I'll be extra impressed.
So options are a shield volcano, a composite or stratovolcano, or a cinder cone.
And Eleanor asked an excellent question. When lava dries up, can minerals help plants grow? The lava that forms the islands of Hawaii is rich in magnesium and iron, which are both nutrients that plants need. And oftentimes volcanic soil can be really high in nutrients and good for plant growth. But first, it has to break down. And it takes time for it to break down. So a lava flow that is only 5 or 10 years old, you're not going to see plants on it because it's rock and it's too hard and the plant roots can't get through.
All right, I'm going to call an end to this one. A shield volcano. How did you guys get that right? We
Woohoo!
didn't even cover it.
They read the notes. They read the notes. They are the unbeatable science kids, Math Dad.
I was going to win that one for sure. All right. True or false? When volcanoes erupt, they always produce lava.
Look at Science Puppy.
Yeah, what do you think, Kaladin? Yeah. It's a nice comfy little bed.
It is.
All right. Got some good questions here that came in. So what actually causes the volcano to erupt? Is it the pressure just grows and grows and then finally kaboom?
Yeah, it does have to do with the pressure. And you can think about it like a tube of toothpaste. If anyone has ever left the top off of a tube of toothpaste before, when you go to squeeze it out, it's harder to squeeze out, right?
Yeah.
But if you squeeze hard enough, then out comes the toothpaste.
And that's why it can come out so violently at times.
Yeah, and in a lot of ways, a volcano is similar, where there are old vents that were formed that are weaker, and it's easier for the magma to travel up through those vents. But it has to do with how much melted rock there is and how much pressure there is with dissolved gases in that melted rock.
Okay, so the correct answer was false.
Yes.
Now, is that because of like ash? Volcanoes can put out things other than lava.
Yes, certain volcanoes, when they erupt, you are not going to see a lava flow. you will see just a big cloud of ash. It all depends on the type of volcano. And stratovolcanoes or composite volcanoes like Mount St. Helens and Mount Rainier, most often those will produce ash fall and pyroclastic flows rather than a lava flow.
So it turns out the lava flow those are the good volcanoes, the ones that are much safer and nicer. I mean, they can be plenty destructive, but not
if you are planning
so explosive.
Yes, if you're planning to live on a volcano, I recommend a shield volcano over a composite volcano or yes.
All right, our final question of the day. Which of these describes how granite is formed? So lava cools down quickly, forming a rock with a dark color and no visible crystals. Magma cools slowly beneath the surface, forming a rock with large visible crystals. Or lava with a large amount of dissolved gas cools quickly.
And
one of those is correct.
A good question from Kieran. What metal can survive going into lava? Tungsten actually has a really high melting point. And there has been thought that perhaps if you had a tungsten probe made out of that element, that it would be able to go into lava. I don't know if people have actually done that yet. That's a little more theoretical. And it would all depend on the pressure and the temperature too. You couldn't go down deep into the mantle because the temperatures get even hotter than 1,000 degrees Celsius. But for scooping out something, a sample of lava, you could certainly do that. And then another good comment from Quinn: the more air bubbles, the lighter the rock is. Absolutely. The more air bubbles, the lighter the rock will be. And great question from Haley: how is green obsidian made? How does it get its color? From olivine, which is a mineral that has a green color. And on the island of Hawaii, there were a couple of eruptions that had very high amounts of olivine and actually produced green sand and green sand beaches.
Yeah, really cool.
Let's finish and reveal.
And the magma is cooling slowly beneath the surface, and that's what's creating those cool crystals in the granite structure.
Nicely done, you guys. So now the question I have for our unbeatable science kids is, do they want to see Math Dad's attempt of the orange justice? Do they want to see the chicken worm? Or do they want to see the Russian squat dance? Because those are the 3 dances we have.
All right.
Emily says, justice, please. So justice it is. And I know we had several people last time say that is not the orange justice. And all I can say is Math Dad did his best. He watched several tutorials and
they have very high standards when it comes to their video game dances. One question I saw coming in was, what was the name of that volcano on Hawaii? We got the Mauna Loa, right?
Yes. So there are several different volcanoes on Hawaii. Mauna Loa is the one that is currently active. Well, it hasn't erupted in decades, but they still consider it active and predict that it will erupt again.
No,
but
it erupted a few years ago, right?
Kilauea is what you're thinking of. So Kilauea is not as tall as the tallest summit on Hawaii. It's down lower. And that is, there's a big caldera that has a lava lake in it right now. But in 2018, that lava lake all of a sudden drained, like it was just gone within one day. And then on the side away from Kilauea, down lower, a vent opened up and all of that lava came out.
At the side of the mountain.
So that was the 2018 eruption. And real fast, there are a couple more questions I want to answer real quick. Great question. I see Alondra asked several questions about how do you know when a volcano is going to erupt? And can a volcano cool down and go dormant? Absolutely. So one way that scientists will predict volcanic eruptions is actually by studying earthquakes. Not huge earthquakes, but small ones that are even too small for us to feel. If they are tracking those can give them an idea of how the magma is moving. Because before an eruption, the magma inside the chamber, pressure has to build and it will start to move up. And that produces small, hardly noticeable to us often, earthquakes. And of course, right before a really big eruption, there will be big earthquakes that we can feel. But we want to know in advance.
Oh, yes.
And there are scientists who study that. And with Mount St. Helens, they were able to give people warning and evacuate a large area. The number of people who died in that eruption was much smaller because of science than it would have been otherwise. They were measuring the mountain and it was growing by almost 8 feet a day. This bulge was happening on the side. And then with seismographs, with measuring the small earthquakes, they could tell, okay, this is going to erupt any moment now. And they predicted it pretty accurately.
Thank goodness.
All right. We are out of time now. I hope you guys enjoyed this lesson and learning more about igneous rocks. And we will be learning about weathering and erosion on Wednesday. Work hard, grow smart. Oh, hold on. I'm going to get Science Puppy up so he can wave goodbye. And we will see you on Wednesday.